And you can see here this is one of the Irodoj problems. I don't remember exactly the problem number, but I'm sure this is one of the problems of IIRODO. And the problem is related to reflection of light. That says so that when reflected from a mirror, that means a plane surface, the condition is satisfied. And these are vectors, basically unit vectors. E naught, and n, all are unit vectors. And here E and E naught are the unit vectors of the reflected. E is the unit vector along the reflected ray, and E naught is the unit vector along the incident ray. N is the unit vector of the normal to the plane of the mirror. Yeah, that's right. And I think this is something missing here. So this doesn't mean anything, and this is the problem, and we need to solve it. We can do this because we all know how to treat with vectors, and I think this will not going to become a big problem. Rather, I think the problem is simple. So let's solve it. And you can see this solution diagram. This is the unit vector. E naught is the unit vector along the incident ray. E is the unit vector along the reflected ray, and n is the unit vector along the normal. And I have introduced a vector here, simply called delta E. I call it. And because these are two unit vectors having same magnitude, and this joins the heads of these two unit vectors, so I just call it delta E. And this is a vector I need to find. And if you can see this picture, I have also taken two angles, alpha and beta. I don't know, but there is a purpose behind considering those angles, and you are going to watch this, or you are going to connect with these angles pretty soon. But first let us look at this vector triangle, and you can always write from this vector triangle that this unit vector E, this vector, is the sum of E naught vector plus delta E vector drawn in this picture. And so if you try to find the magnitude or modulus of I don't know whether this vector is unit vector or not, because these two are unit vectors, but I am so I simply written as delta E vector. So because I am not quite sure, because this is the difference of two vectors, it may be anything, because one and one can be added to provide anything between 0 to 2. So this may be a unit vector or not, I'm not quite sure, but this is a vector delta E. Well, let's try to find out the magnitude or the modulus of this vector E. And this modulus of vector E will be simply if I can use this angle here, alpha angle here, and I can use the cosine formula, and cos alpha can be written as magnitude of this E naught vector, that is magnitude of E naught vector, so write it magnitude of E naught vector square, that is 1 square, plus magnitude of E vector, that is also equal to magnitude of E naught vector, because both are unit vectors. So I can write it also here, E naught square plus E naught square, no sorry, I made a mistake. I don't know why I'm making the mistakes. But this angle, I need to find this cos alpha, and cos alpha equal to magnitude of E naught vector square plus magnitude of delta E vector square minus magnitude of E vector square divided by magnitude twice of magnitude of E naught vector multiplied by magnitude of delta E vector. So this is my cos alpha. And I can always write that magnitude of E naught vector is 1, and so is the magnitude of vector E. So that means I can, if I complete all those things, this will get cancelled out, and this square will cancel out from this, and that means you can see here the magnitude of delta E vector is twice of magnitude of E naught vector, that will turn out to be 1 unity multiplied by cos alpha. So and that means you are going to write something that magnitude of delta E is equal to 2 cos alpha simply, and cos alpha, and alpha is equal to obviously pi by 2 minus beta, pi minus beta, sorry, alpha equal to, because alpha plus beta equals pi, so alpha equal to pi minus beta. If I put beta here in place of alpha, then it will become minus 2 cos beta simply, minus 2 cos beta. Why should I take cos beta? Because you can see here beta is the angle between this vector, that is delta E vector, and the E naught vector, and delta E vector is parallel to the normal vector, so directions of delta E vector and n vector are same. That means if you are willing to write something like I think problem statement, the role of problem statement has been over now, so I can remove it from the screen and use the place for solving this problem. And you can see one thing here, that the dot product of this delta E naught vector and E naught vector, but I would like to write it the dot product of E naught vector and the unit normal vector, so that the angle between and their dot product will be the magnitude of E naught vector, that is 1, and magnitude of normal vector, that is also equal to 1, multiplied by the angle between them, that is cos beta. So I got here that the dot product of E naught and unit normal vector n is simply cos beta. That means I can write here that magnitude of delta E vector is equal to minus 2 cos beta. In place of cos beta, I can place this thing, E dot unit vector n dot n, and since delta is a vector itself and the direction of delta E is along the unit normal vector, so I can write here delta E vector equals its magnitude, that is minus 2 E dot n, and you don't bother about whether this magnitude is negative. It's positive, you can see here, because cos beta here, that is equal to E dot n, is itself negative. So after putting this minus sign, it will become positive. So delta is equals this, and since delta E vector is this, and E vector is equal to E naught plus delta E vector, so just place the value of delta E here, and you will get your result. And this was required. So it was a simple problem to solve. Thank you very much for watching.